Hello, my dear Vedantu students. Welcome to the Vedantu Karnataka channel. Hey, Laru. Yes, this is your Captain Shreyas. I hope I'm audible and visible to all of you, and I'm also live. To let me know quickly in the chat box. And since your midterm exams are about to be, over in the next couple of days, so we are conducting the midterm sessions for all of you. We had the 5-marker question sessions, we had the revision session, we had the important concept and 2-3 marker sessions. It's time for the final round where we will do the top-notch MCQs, and hope this kind of questions will help you for solving those MCQ questions, especially which are going to come in your midterm exam. And the best part about MCQs is that they are very direct questions. You either get it or you don't get it, and they can be time saver in your examination, and they will easily give you couple of marks in your board examination. See, it is not like you solve that and you get 5 marks, but every 30-50 seconds or 1 minute, 1.5 minutes, easily you will get quick marks in your scoreboard. Correct? Hi Bid, PU, hi Pooja, welcome aboard. Right? So this is your Capto. Yeah, ನನ್ನ ಹೆಸರು Captain Shreyas, and I'm your physics master teacher, and I have been training kids for more than 13 years in JEE, NEET, and I have myself done my college, or you can say PU, you can say before I entered into NIT Nagpur in state board syllabus. So I know what it takes to crack the state board examination, because it is way different from the CBSE or ICSE kind of examinations, right? So let's begin with the lecture. I have chosen some nice questions for all of you. If you have attended all the MCQ sessions, you would have solved more than 100 questions by now. And I don't know whether you know this, it's there right on this particular channel only. Just go to the live section and you will see the top 100 MCQs. Already botany was done, chemistry was done, today maths was done, and now we'll do physics, and yes, the zoology part will be done tomorrow. Also remember, we have kept playlists for all of you, so that in case anybody wants to search any content, you will be able to find in this particular playlist. Okay, keep that in mind. Yeah, and the PDF of today's session, many people keep asking, it is going to be uploaded on the Telegram channel. The link is there in the description box over here. So click on this link. Yeah, click ಮಾಡಿ ಇದು ಜಾಯಿನ್ ಮಾಡಿ. ಆಲ್ ರೈಟ್, ಯಾ, ಟೆಲಿಗ್ರಾಮ್ ಚಾನಲ್, ಆಫಿಷಿಯಲ್ ಚಾನಲ್. ಇಲ್ಲಿಂದ ನಿಮಗೆ ಇದು ಪಿ ಡಿ ಎಫ್, yes, you will get the PDF over here. Yes, all right. So let's start with the first question. An electric dipole, when placed in a uniform field, will have minimum potential energy if the direction of the dipole moment makes which of the following angles. Hi Shrusti, welcome. Okay, so in this particular question, the question is on potential energy of a dipole in an external field. You need to remember this formula. Potential energy is negative dipole moment electric field into cos theta. This is the formula. As per the given information, you want the potential energy to be minimum. You want the potential energy to be minimum. Now, if you notice, cos, right, can have maximum value of +1 and least value of -1. So think about it. If I make the cos maximum value is +1, least value is -1. If cos is +1, then the potential energy will be minus PE into 1. If it is -1, then it will be minus PE into -1. Here it was +1. Minus into minus will make it positive, so it will become plus PE. Minus into positive will make it still minus only, so it will be minus PE. So out of these two, who is more? Is this more or is this more? Obviously, plus PE is maximum. Plus PE is basically maximum. Minus PE is basically minimum. So the maximum value is plus P, minimum value is minus P. We want minimum, right? We want minimum. That means cos value should be +1. When is the value of cos theta +1? The cos theta is +1 when theta is 0 degree. Hence, you will mark the answer as 0. If the question said when is it maximum, that means cos theta will be negative, negative, negative makes it positive. So this is where it will be maximum, and cos is negative 1 when theta is pi radian or 180 degrees. So that answer would be there as option A if the question was for maximum. But here it is for minimum. Negative values are lower, positive values are higher. Is this okay, everyone? Yeah. Tomorrow mathematics. Yes. Please watch Namrata ma'am session. Sudarshan. Nodidara Sudarshan Namrata ma'am ge session. Yes. Please watch maths classes from there. Even computer science session is going to come day after tomorrow or tomorrow. Can you suggest how to solve numericals in? Is there any numericals for tomorrow? Manjunath, important numericals bekandre idu nodi. See, this is MCQs, okay? This is not big numericals. Important numericals bekandre idu nodi. This 2-3 mark questions, okay? Number 1. Number 2, this one. 4 and 5 mark questions, important numericals ide. And idu. Yes, this one. Most repeated topics of electromagnetism. This one. Okay. You will see some most important concepts over here. In that, all those concept-based questions on electromagnetism you can get. Okay. So that is what you need to see. Okay. Okay. Right. Hi Krishna. Thank you for the WBWP. Thank you so much. Nice to see you. Tanuja also. Nice to see you. Oh, you guys over here. Yes. Tumba khushi aitu. Okay. Thank you so much. Number of electrons in 1 coulomb of the charge is how much? Number of electrons. Okay. Yes, I will plan for class 11th also. Idu aadmele nanu ಮಾಡ್ತೀನಿ. Okay, this midterm exam ಆದ್ಮೇಲೆ ನಾನು strategy ಮಾಡ್ತೀನಿ for 11th standard kids also. Okay. So, number of electrons in 1 coulomb of charge. There is a formula for the number, and that formula is the charge is the number into the electron charge. Here the question is how much is that number? So it will be Q, put that E below, Q by E. What is that charge? 1 coulomb. What is the value of E? 1.6 into 10 to the power minus 19. So you can also write it as 0.16 into 1 by 10 to the power. You can put it as, all right, we can just put it as 10 to the power minus 18. Yeah, that's fine because I have just shifted the decimal. So this will become 1 divided by 0.16. Negative power on the top will become positive 10 to the power plus 18. This number approximately 1 by 0.016. This number will become 6.25 and this is 10 to the power plus 18, which is option B. B for Bengaluru. Namma Bengaluru, yes. Can you do revision of the 4th norm on, as we have physics exam on 5th November? Okay, I want to know, do you guys want a formula revision of entire physics portion? And ninatra yen syllabus ide nanga gotilla. So that's why I want what exactly is your syllabus, because some students keltini sir ray optics ide, some students keltini sir ray optics baralla nange semiconductors barutte. So you know, I want exact syllabus whatever you have, so that accordingly I will plan the syllabus revision, formula revision for all the topics, complete revision right from chapter 1 to chapter n. Okay, yes, option B correct. All right. A metallic sphere of radius r has a uniform distribution of the charge on the surface at a distance x from the center, where x is more than the radius. Electric field is directly proportional to. Okay, let's have a look at this question. See, whenever you have a sphere and the charges are like this and you are at a point x which is more than the radius, then at any point like this over here, the electric field is the field as if the charge of the sphere is at the center, as if the charge of the sphere is at the center. So assume all the charge to be concentrated over here. Assume all the charge to be concentrated here, and now think as if you are at that distance x. So what will that electric field be? It will be k q by distance, which is x square. That means the electric field is inversely proportional to the square of the distance. So option A barutte. Yes, option A. Is that okay, everyone? Understood? This formula you should know. Can you guys think and tell me what would the answer be if instead of x more than r, if it was less than r? Then what would the answer be? Then when it is less than r inside, remember the electric field will be 0. Everywhere inside a shell, the field will be 0. Okay, so it will not be there only inside that particular shell. Keep that in mind. All right. Moving on. For a given surface, the Gauss law is given by E dot ds is 0. Question is, which ones can we conclude from this? Electric field is 0 everywhere. Electric field is perpendicular everywhere. Total flux through the surface is 0. The flux is only going out of the surface. Now, if you remember, this statement is of the Gauss's law. This statement is of the Gauss's law. Try to recollect Gauss law, my dear warriors, my dear students. You will understand the correct answer. This thing over here is the flux in the closed surface. And what is flux? If you take any surface, it counts how much field is entering in or exiting out. So, if the total flux is 0, that means whatever enters in is exiting out. Whatever enters in is exiting out. So, whatever goes in is exiting out, because inside flux is negative, outside flux is positive, hence the net flux is 0. So, now with this understanding, can you think and tell me which of the following answers will be correct? The total flux through the surface should be 0. Yes, option C barutte. Correct. Very good. Awesomeness. Okay. Ishita, same whatever you typed, right? Please type it in the comments, because the chat will go off after some time, right? I won't be able to see. I can see, but still. So put it in the comment also. Okay. Same statement ke comment madi. Okay. After session is over. All right. Moving on to the next one. Two charges of equal magnitudes and distance r exert force on each other. The charges are made half and the distance between them is also doubled. Then what do you think the new force is? So just imagine these are the two charges. This is Q, this is also Q. The distance between them is basically r. Then in that case, there will be a force of repulsion between them. That force will be Coulomb's law. K, Q, Q divided by distance square, which is K, Q square divided by R square. Adu force barutte. Okay. Now, what have you done? The next thing. You have made the charge as half and the distance is doubled. So, the distance is now 2r and the charge is made half. So, what will happen to the force? The force will be something else. Let's say I call it F1. So, this F1 will be K Q by 2 upon 2R whole square. What will this be? Q into Q is Q square. R into R is R square. This 1 by 2 is there. This 1 by 2 is there. 2 square is basically 4. So, 1 by 4 is also there. 2 square is 4. So, in the denominator. What is this KQ square by R square? This is nothing but the force. 2 2s are 4, 4 4s are 16. So, F by 16. So, the new force is the old force by 16. C option is the correct answer. C option is the correct answer. Yes. Yes. So, there is one request from CBSE students. Please starts for CBSE students. Trisha, you can do one thing for CBSE. Do one thing. See, there is this channel called as Vedantu NEET English channel. Okay, I am only teaching, Diksha ma'am is teaching, Gopika ma'am, Baswa sir, all same teachers only. In that, if you go little bit down, you will see this particular series. Where did it go? I don't know, why is it? Okay, this NCRT line by line, but how do I go to this? Let's say I go over here, any video you go, okay, and go down a little bit, you can see this treasure box. This treasure box is there. In that, the complete list is there. NCRT line by line. This is basically for your CBSE. So complete YouTube links are there with the session tagging, which physics, chemistry, maths, biology, everything. So you can just watch it from here. Okay. Good news, Tresha. I hope you are very happy with this. Complete CBSE, NCRT, and this will be helpful for your competitive preparation also. That way. Cool. Okay. Moving on to the next one. An electron is moving towards the x-axis. Electric field is along the y-axis. What will be the path of the electron? What will be the path of the electron? That is the question. Let's see how do we do this particular question. See, the electron is going along the x-axis. This is some charge. The electric field is along the y-axis. So the force will also be along the y-axis only. So the force will also be along the y-axis. But actually, since it's a negative charge, because it is given, it is an electron. So technically speaking, the force will be over here. The force will be over here. This force magnitude wise will be the charge into the electric field. And neither the charge is changing nor the electric field is changing. So it is a constant force. So it is a constant force. Now, till this point, leave it. Now observe this. Imagine you are on a top of a hill and you take a mass and you throw it like this. And you throw it basically like this. You are on the top of a hill. How will that particle go? How will that mass go? That mass will go like this, right? I hope you remember this from 11th grade. You throw it like this, it will go in a curved path. What is that curved path? Because of gravity. And there is one force acting on it, which is the weight, which is also constant force. So this is a parabola. This is a parabola. This situation is very much similar to this. So even this charge will go in a curved path because this force is like the weight. It is not the weight, but it is exactly similar in nature. You are throwing this charge under constant force. So yes, it will go exactly like projectile motion. Hence the answer to this will be a parabola, not ellipse, not circular, not straight line, not rest. Yes, it will be a parabola. Is this clear? Give me a thumbs up. And if you have not yet marked your attendance, please mark your attendance by smashing this like button. Yes, this channel is for you, for students of Karnataka, for PUC, for KCT, for Comet K. So make sure you are subscribed, you are liking and sharing this channel. Make the full use of this. Okay. Next question. The SI unit of electric flux is how much? What is the SI unit of electric flux? A lot of people think the answer is Weber, but it is not. The question is electric flux. If the question was for magnetic flux, yes, the answer is a Weber, but this is not magnetic, it is electric. And the formula for electric flux, if you remember, the formula for electric flux is nothing but electric field into area. Electric field has the unit of volt per meter. Area has the unit of meter square. Meter will cancel, it will become voltmeter. Hence, volt into meter, which is option C, should be the correct answer. Okay. So as we discuss any question, I am also telling you other questions related to that which might also come. So don't just by heart and remember this question. Like when I discuss this, I am telling you, if this was magnetic flux, then the answer will be Weber. Even in the previous few questions, I have been telling you, what will you do if it was something else, right? What will you do if it was inside? The answer will be 0. Or what will you do if it was maximum? Then how will you solve the question? So just because I solved this question does not mean I have to only do that much. Something else if it comes, okay, you should be able to solve it. All the related models, you should be able to do it. Electric potential at a point due to a short dipole varies with distance as. If you have a dipole, and you are standing at any location, let's say on the axis or on the equator, the electric field, for example, on the axis is given by Coulomb's constant into 2 times the dipole moment divided by x cube. This is the electric field. But the question is on electric potential. Similarly, the electric potential on the axis is given by Kp divided by x square. Kp divided by x square. So if the question was on electric field, then the answer will be the inverse of the distance cube. The question is on potential, the answer will be inverse of the distance square. Distance square. So distance square is there as a D option. Yes, that is correct. If it was the question on electric field, not potential, answer will be 1 by distance cube. Okay, I hope this is clear. Yeah. Yes. Right, very good. So we'll be starting mainly right now, you can say the second PU syllabus, and the 11th PU syllabus also will start simultaneously, because 11th PU syllabus, that is the first PU syllabus, is also there in your KCT examinations. We'll start off with that as well, don't worry, just after this week. Okay, next question. Capacitance of a parallel plate capacitor does not depend on, will affect the voltage, but it won't affect the capacitance, because capacitance depends on the material inside, the size, the distance, and other geometrical parameters. Okay, so that is the answer, option D. What the maximum electric field that a medium can hold without breaking down. Now this concept is of lightning, thunder, sparks between wires. If you take 2 wires and they are very close and there is some gap in between, or this is the cloud and recently it has been raining so heavily, we have seen that there is lightning from the sky, or there are basically sparks which go. These sparks or this lightning is a very good example where the electric field has exceeded that breakdown, and that is why current is flowing even inside air. Usually current does not flow in air, because we know if current flows in air, then we would be shocked, we will die, we will feel that current, because current, electricity is there everywhere in our houses. So you need to have very strong electric field for the current to flow in that air. So that happens in extreme conditions like lightning for few seconds, sparks when 2 wires are brought very close to each other. Hence the answer to that is the dielectric strength. Please remember, dielectric constant is completely different thing. Dielectric constant is basically that K. That is how many times the electric field will reduce inside a medium. Permittivity is nothing but epsilon. Electric susceptibility is again, a parameter defining how much the electric field will weaken or become strong inside a medium. These two are basically related to each other. It is not got to do anything with breakdown. So hence the correct answer to that is basically dielectric, strength. Okay, everyone? Very good, Akshata. You answered the correct questions. Awesome. Kirchhoff's junction rule is conservation of what? Kirchhoff's loop rule is a consequence or conservation of what? Both the questions very, very important, most repeated concept questions, guys. So whenever you talk about Kirchhoff's junction rule, that means the current entering in is the current exiting out. It is basically the conservation of charge. Whatever goes in should be going out. Nothing stays, accumulates. So the charge is conserved. Whereas the second part, the loop rule. So in a circuit, if you go around a circuit and you come back to the same point, the total sum of the voltage drops will be 0. This is because whatever energies you acquire, you will lose that energy when you come back to the same point inside a loop. Hence, this is based on energy conservation. Energy conservation. Hence, the answer is C and B, I believe. Yes, C and B. Charge and energy. You should know this. They might give you 2 mark or 3 mark question, and you will only come and tell me, yes sir, this question was there. What is the SI unit of conductivity? What is the SI unit of conductivity? What is conductivity? Conductivity is 1 by resistivity. This is basically your conductivity. What is this? This is your resistivity. Now, either you remember the unit of resistivity. If you don't remember, no issues. This formula you should know. Resistance is resistivity into length by area. Resistance is measured in ohm. Resistivity, I do not know the unit. Length is measured in meter. And then area is measured in meter square. Meter square will cancel and you will be left with meter over here, and this is ohm. So the unit of resistivity will be nothing but ohm meter. So if this is ohm meter, it is downstairs in the denominator. So conductivity units is 1 by ohm meter, which is a D option. If the question was on resistivity, the answer will be ohm into meter. Ohm into meter. Okay, I hope this is absolutely clear. Absolutely clear. Okay. Yes, very good. Awesome, awesome. Cates Zozo, nange Kannada barutte, but yenaitu most of the students alva adu English medium ge they will be studying. So that is the thing. Most of the students in Karnataka study in English medium, and Karnataka medium, Kannada medium is also there, but you will be mostly writing KCT exam in English, you will be writing the competitive exam in English. That is the reason why we also teach in English, because anyways when you go into a college, let's say engineering, medical, or you will go abroad, you will go for higher studies, or you will go work in MNC and all, alva. So you will be obviously, using English for your academic content or academic lessons and all of that. That's why. Okay. Awesome. Moving on to the next question. The correct expression for the current density. Very confusing options. All of them look very similar, but only one of them is correct. Let's see whether you guys get this correctly. Current density and the drift speed. What is the formula? I told you current is NVIDIA. Current is NVIDIA. Bring that area down. Current by area is NVDE. Current by area is current density. So J is equal to NVD. There is no A. Yes. What is the correct answer? NVDE. Option A barutte. Correct. Yes. Perfecto. Perfecto. Awesome. Yep. I've done my education in multiple places, Devan, but yes, most of my ancestors, mother side and dad side, they are from Karnataka, Mysore, Bangalore. Yeah, most of my relatives, my ancestor, grandmom, everyone is from, Hassan, Mysore, all of that. Yeah. Okay. That is my thing. I don't know whether you guys also are from nearby places only, because I stay in Bangalore. I know most of Bangalore, Mysore, little bit of Mangalore too, and Udupi. Yes. And Hubli also, I have many relatives. A lot of times I have visited Hubli. Yep. So you should let me know if you are from any of these places or maybe some other place too. Okay. So let's have a look at this. On increasing the temperature of a conductor, its resistance increases because why does it increase? Because when you increase the temperature, it will become more energetic. Energy will increase. It will collide frequently. It will collide frequently. So because of which the relaxation time will go down, because of which the resistance, because it relaxes for very little time, the resistance will go up. So the correct answer is relaxation time decreases. Relaxation time decreases. Yes, Akshita, correct. Akshata, correct. That is the answer. It has got nothing. How can mass of the electron change? How can electron density change? None of the above. No, because A option is correct. Oops, sorry, I showed the answer by mistake. Anyways, in a semiconductor at a room temperature, valence band is partially empty, conduction band is partially filled, valence band is completely filled, conduction band is partially filled. See, there are many regions, bands in a conductor, semiconductor and a insulator. If you talk about a semiconductor, right, you have the valence band and then you have the conduction band like this, and this is basically your band gap, which is typically few electron volts, 1 to 2 electron volts, not more. For a semiconductor we are talking about, this is for a semiconductor. You will see that in such a case, semiconductor, valence band is completely filled, conduction band is partially filled. No, you will see that this is probably filled this much. This is probably filled this much. There are some electrons which are jumping over here, and this is filled this much. This is due to the thermal energy at room temperature. In case of insulator, there is no electron only in the conduction band. Because of no electron in the conduction band only, they can't conduct, hence it is an insulator. For a insulator like rubber, wood, wool, thermocol, plastic, etc. Semiconductor means your silicon and germanium, those kind of things. Whereas for a conductor, this band is very well filled. In fact, both these bands might overlap, valence band and conduction band. Usually they overlap. So many electrons are there in the conduction band, and that's why it behaves like a conductor. Here it is very few, it is negligible, but it is there. That is why it is a semiconductor, not a great conductor, but not a bad conductor either. Hence option A is correct. Let's see if we can do it next. Sir, please focus on KCT after this week. Yes, definitely, Pratham. I knew that many of you, even if I start KCT, you will be like, sir, my midterm going on. Sir, please wait, sir. You will not be serious. That is the reason why we did not start KCT deliberately, because I know your midterm is there in all the schools, colleges, everywhere in Karnataka. So that is the reason for that. Okay. So after this, we will be launching our KCT series, which will be helpful not only for your colleges, but also for your PU board. So we'll teach from KCT perspective only. All right. So what is the correct answer for this? Now this is based on your general knowledge. Either you know it or you don't know it. The correct answer is phosphorus and indium. Remember, boron, aluminium, indium, they are trivalent impurities. So when you add them in germanium silicon, they become P type of semiconductor. So this is usually used for P type of doping. So you can see phosphorus is there here, this is P type. You can say indium is there over here, this is P type. You can also see boron is there over here, this is P type. This is basically for N type of doping. So you can even see P type is there here also. Aluminium is also P type. So you can see arsenic is N type doping. Aluminium, again, it is basically P type of doping, but we wanted one N type and P type. So indium is basically P type, and this phosphorus is basically your N type. I hope this is clear. That is the reason for this. Is that okay? I think I marked over here wrongly. My bad. Sorry, this is N type. Yeah. So this was NN. This was PP because aluminum is also there and indium is there. And here aluminium is there and boron is there. Again, that is PP. This is NP. We wanted N and P. So that is the reason why correct option is, option C, phosphorus and indium. You should remember this. You should remember this. Yes. Okay. How to remember this? Up to you. You can just make some mnemonics. See, there is B over here. There is A over here. You can just remember like things like Bali. You can remember Bali. Bali. Bali is a place. Bali, Indonesia, like that. So Bali is positive, P type. You can remember it like that. So Bali is positive. Yes, correct. And over here you have pH, arsenic and antimony. You can remember it in different ways, like you can remember it as P, A, R, A, N. Okay, now you can play around with it, like you can remember it like Pan, R, something like that. Okay, Pan, R, Panar. Okay, or you can remember it as Par, An. So you can make your own mnemonics like this, and that will be your negative, which is N type. That is how you can remember it in the examination. Is that okay? Cool? Awesome. Let's have a look at the next question. In a PN junction which is forward biased, the current across the junction is due to what? The current in that junction, across the junction, is because of what? Diffusion of charges, drifting of charges, both diffusion and drifting, or holes only? Well, forward bias is because of diffusion. Remember this always. Forward is because of diffusion, and reverse bias is because of the drift current. You should know this. So whenever you have a diode which is forward bias, it's mainly because the currents which are formed are because of diffusion, and if it is reverse bias, that means current is going in the opposite way, then it is because of the drift current, and the drift current is usually very, very less. The diffusion current can be very, very high, and that is why it is called forward bias. So the current is more in one direction and there is hardly any current in the opposite direction. So that is why it is called as a diode, because it is like a one-way road. It allows current in one direction. In the other direction, it hardly sends current, which is very less. So it is a one-way traffic road. That is why it is also called as a diode. Okay. Solar cells are operated in forward bias, reverse bias, unbiased. None of these. What is the correct answer for this? How many of you have semiconductors also in the midterm? Let me know. Because I think some of you had mentioned, sir, we have semiconductors also. So solar cell, it's like a cell, and a cell produces electricity, it generates electricity. So you don't have to connect a battery to a cell. That is wrong. You never ever connect a battery to a cell. Rather, the cell only is the battery. And from that, you can connect some appliances over here. You can connect some appliances like fan, bulb, etc. So there is no biasing which is required. So no biasing is needed. So hence it is unbiased. If you connect a battery, then you will need it. Okay, so most of you do not have semiconductor also. Okay, no issues, because some of you said, sir, we don't have magnetism and magnetism effects, magnetic effects and all that. Electromagnetic induction was not there. Maybe depends on your school and PU board, or depends which zone, which part you are. So maybe depends on that. Okay, ray optics hopefully. The color which has the least critical angle of incidence is very important. Critical angle is that angle after which the light gets totally internally reflected, and it depends on the refractive index of that light in that medium. Now every color has a different refractive index. Yes, yellow, blue, red, everything, because when they pass through one medium to other, they will deflect by different amounts. So using that knowledge, you will be able to do it. So for that, the trick is, remember this, Vib Gayor, violet, indigo, blue, green, yellow, orange, red, Vib Gayor. It is in the reverse order. When you pass white light, the violet light deflects the most. So the refractive index of violet is the highest. If you see the red light is deflecting the least, that means the refractive index for red color is not so much. That's why it did not bend. Refraction is bending of light. So the refractive index of red is not that much. Yellow is somewhere in between. Green is somewhere in between. Okay. Now what is the formula that we need to use? The formula is sine of the critical angle is 1 by the refractive index. We want least critical angle. We want least critical angle. Least critical angle, that means this should be minimum. That means this whole thing on the LHS should be minimum. That means on this side, this mu should be maximum. If this mu should be maximum, for whom is it maximum? Violet. For red, it is the least. Hence, the answer is violet. Is this clear also, everyone? Is this clear? Okay. Yep. Yes, we'll be starting off with the first year topics also in just couple of days. Let me launch the KCT series, and then we will also start with the first year topics as well. Don't worry. Yep. All right. Moving on to the next question. The deviation produced by a prism is, very important question. Whenever you have a prism, the light which enters, will deviate by some amount. That deviation is given by, that deviation produced is given by, come on, this is your angle of prism. This is your angle of prism. This is the angle of incidence. And over here, this is your angle of emergence over here. So what is that delta going to be? Yes, it is going to be I plus E minus A. I plus E minus A, which is option number A. Yep, very good, everyone. Yeah, all options look the same, very confusing. Hai na? It looks so confusing. But this is the correct answer. If you have practiced enough numericals, this formula will be like this in your head and you will get that marks in your examination. Refractive index is ratio of what? What is refractive index? Ratio of what? Mu is speed of light in one medium upon speed of light in other medium. Speed is frequency into wavelength. But remember, frequency never changes when light goes from water to glass, glass to air, basically when medium changes. So the only thing which changes is the wavelength. So FF cancels and I can write it as lambda 1 by lambda 2. So it is the ratio of the speeds, yes. It is the ratio of the wavelengths, yes. Frequencies, no. Hence A and B both are correct. So hence option D. Hence option D. Is that clear? Everyone? Okay, keep this in mind. Speed of light is frequency into wavelength. Standard formula. C is F lambda. Wave speed is F lambda. Correct. Moving on to the next question. At which position of the object a convex lens produces a magnification of -1? -1, I want the magnification. Where do you think it will produce this? This is basically a convex lens. This is basically a convex lens, and let's say this is f, this is 2f, and we want a magnification of a -1. Where do you think we should put it? If you are accustomed to the ray diagrams of a convex lens, you will remember when the object is very far, then the rays meet and form the image at the focus. So remember, there is f over here also, and 2f is double the focal length on this side also. So when object is at infinity, the image is formed at the focus. When you place the object over here, then the image becomes virtual. Okay, that can't be the case. When the object is over here, then the image is formed at infinity over here. If you remember, when you come from infinity to 2f, you will see when you place the object here, the image is formed exactly over here of the same size, but it is inverted. Yes, it is inverted, correct. So here you can see the magnification is -1 because it is image height by object height. So if image height is -x, object height will be +x, which is going to be -1. Why negative? Because it is down. Why this is positive? Because it is up. Sign convention. Hence, the correct answer will be at 2f. At 2f. Is that okay? Standard type of question. All right. This question is your homework question. I want everyone to put up the answer in the comment section. Take a screenshot. I will move away. I can pause the video, solve it, and put the answer in the comment section. I will leave the answer in the PDF of the session. The PDF will be available where? In our Telegram channel. Where is the Telegram channel? Well, as you are watching this particular video, my dear students, yes, as you are watching this particular video, where did it go? Live session? What just happened? Yeah, as you are watching this particular video, go down in the description box and you will see join the Telegram channel link. So click on this particular link, you will be able to join the Telegram channel. All our PDFs are shared over here only. Okay, is this clear? Understood? Sure. All right. So I hope you enjoyed a lot, you learnt a lot. All the best for your midterm KCT series, first PU and second PU starting very soon. Okay, so stay tuned on the channel. Take care, my dear lovely warriors. All the best. Channamadi exam. Okay, bye bye. Take care. Thank you for liking. If you have not liked the video, like it right now and subscribe to the channel. Take care. Bye bye.